Hi guys, I want to talk you through our next analyzation technique. So I want you to begin by thinking, if we were going to analyze a solution, what kind of things would we want to find out about that solution? Pause the video, take 30 seconds and jot down a couple ideas. What would you want to know about a solution if you were a chemist? And hopefully what you said was basically, I would want to know what's in the solution and how much of it is there. And that's exactly what these analyzation techniques are designed to find. So we have done an analyzation technique already in lab. It was our first 2 labs. We used a spectrophotometer, and that's exactly what we looked at in these solutions. What was there and how much of it was present. Right? But not everything can be evaluated by a spectrophotometer. This would be a good place to pause the video, think for 30 seconds, and try to come up with some ideas. What are some reasons that you can think of that we would not be able to use a spectrophotometer to analyze a solution? And hopefully, a couple reasons that you may have come up with. The solution's too dark, or it's a solid, and the light can't get through it. You may have also listed the opposite reason. The solution is too light. For example, mercury is a really important thing to evaluate in water sources, but mercury usually exists in pretty small amounts. So we probably wouldn't be able to detect those teeny tiny amounts of mercury using a spectrophotometer, even though those teeny tiny amounts of mercury are a really big deal. Mercury, if you get it in your body, it doesn't get processed and spit back out of your body. Your body actually stores it. And so if you get a little bit of mercury inside your body over and over and over for 10 years, 20 years, 30 years, that little tiny bit of mercury that our spectrophotometer can't detect becomes a really big deal. You may have also thought of the ion doesn't absorb light. So if you think back to when we analyzed copper nitrate with the spectrophotometer, right? We put into our solution copper and nitrate. Right? But our spectrophotometer only picked up copper. Well, that's because nitrate doesn't absorb light very well. So if you're doing an analysis and nitrate was the thing you were looking for, a spectrophotometer wouldn't be a good choice because nitrate's not going to absorb the light very well. So for all of these reasons, we need other analyzation techniques. And so welcome to technique number 2. That would be titration. So we're going to talk a little bit about titration, but before we do, I want to talk you through a couple pieces of glassware that are pretty similar, but you're going to use them for very specific reasons, and you want to know which one to choose in the right situation. So I have 4 pieces of glassware here. I have a graduated cylinder, I have a burette, I have a pipette, and then I have a volumetric flask. Okay, so another good place to pause the video and think for 30 seconds, can you list off what all 4 pieces of glassware should be used for? Okay, so let's go through them. I'm going to set up a little background here so you can just see the glassware a little bit better. This is my very official dark background. Okay, so graduated cylinder. We've talked about this one before. Really good for measuring things, but a graduated cylinder does have limitations. It doesn't mix very well. Also, if you are trying to measure very large things or very small things, a graduated cylinder has limitations. So this one is marked every ones place, which means you can estimate the tenths place. So anything that's smaller than 1/10 of a millimeter, you're not going to be able to measure very well with a graduated cylinder. So really good for measuring, not great for mixing, has some limitations. Okay, the next thing I want to show you is called a burette, and hopefully you can see our burette here. Our burette also has markings here, and it's used for a very similar reason to the graduated cylinder. It's used for measuring things. Now, you would not ever mix something inside a burette. Don't ever try and do that. It mixes even worse than the graduated cylinder. However, this burette is marked smaller than the graduated cylinder. It's marked every tenths place, which means you can estimate the hundredths place. So a burette is really good for measuring small volumes. If you want to add a small volume, a burette is a really good thing to use. The other thing with a burette is you can add volumes together, add solutions together, and you can add solutions together drop by drop by drop. Now, if I was going to try and do that with a graduated cylinder, first of all, I probably wouldn't be very good at pouring out just one drop. If I did somehow, and for some reason master that skill, my drops would probably not be very uniform. And those are things that a burette is good at also. A burette is really good at adding very small amounts of volume and very uniform amounts of volume. So we can add a drop, and each drop is really fairly equal to the next drop, which is a power of a burette. This is called a stopcock. Right now it is closed. If you turn it so it's pointing up, it is open. And this is what we use to control the flow of fluid, of solution, out of our burette. Okay, so burette, also good for measuring things. It's good for measuring smaller volumes, and it's really good for adding small amounts of liquid very consistently. Okay, this is called a pipette. So a pipette is also used for sucking up and dispensing of very small specific amounts of volume. This one is marked to measure 10 milliliters. Now, some of them are graduated, some of them are not. This one is not graduated, so you can only measure out 10 milliliter aliquots. You can't measure out anything else. You also need something up here like a bulb to suck up the liquid and then squeeze it back out. Or in biology, especially when you're using super, super, super tiny amounts of volume, a lot of times we attach like a rolling wheel here, and the rolling wheel allows us to control how much liquid we pull up and then dispense out of a pipette very, very carefully. We're not going to use pipettes this year in chemistry. Not this kind, at least. But it's good to know the difference between a pipette and a burette. Okay, and then the last thing we're already familiar with, this is a volumetric flask. It's used for diluting stuff because we can add in a stock amount or a sample or a solid, and then we can dilute up to a very specific mark. So again, volumetric flasks, really, really good at mixing stuff. Very precise measurement, but it only has one measurement because usually we're going to dilute to a very specific volume, and so we can choose a volumetric flask at that volume. All right, so today we're going to talk about titration, so we're going to use the burette. Now I want to talk you through a titration setup, and then also walk you through like a mock titration so you kind of see what's going on. So as I pull out the different titration equipment, I want you to try to name it and tell me what it's for. All right, we already talked about the burette. Now, the second piece of equipment, actually second and third is already out here. So this pole and the base here, what is it called and what is it for? And hopefully you called it a ring stand. That's what it is. A ring stand is made out of an upright and a base, and it's really good at holding stuff. Now this is piece of equipment number 3, I guess we're on. And this is a burette clamp. So notice that it's just super convenient to take the burette in and out of our burette clamp. And that's exactly what it's for. It's really secure in holding it. It's really easy to take it in and out. And it doesn't apply too much pressure like a screw would apply too much pressure and actually crack the glass. This holds it at just the right amount of pressure so the glass doesn't actually crack. Okay, here comes piece of equipment number 4. What is this beast? This beast is our resident hot and stir plate. So you'll see the knobs down here. One of these, if you turn it on, it actually heats the plate, much like a glass top stove. I'm gonna turn the heat off because we don't need that today. But it heats things pretty well. It heats things pretty evenly. It's not quite as fast at heating things up as a stove, which can be good in chemistry. The other button here is your stir function. So in order to operate our stir function, we need another piece of equipment, which is this one. This is called a stir bar. It's a magnetic stir bar. So you'll see that it's attracted to a specific part on the plate. And if it's in that specific part on the plate, I can turn this and get it to spin. So what we're gonna do today is use it to help us in our titration. So a nice thing about having a stir plate and a magnetic stir bar is that it will mix the solution for you. And so what we're doing today is we're going to take an acid and add in very slowly a base. And so we're going to get a reaction that occurs in this beaker. And when a reaction occurs in this beaker, we want the reaction to occur like throughout the solution at the same time. And so stirring this helps. If you don't stir it, you're going to get a reaction on one side, and then as the molecules move through the solution, it will slowly kind of react and hit its like equilibrium point, its like happy point of the reaction. But we don't necessarily want that to take a long time. We also don't want to sit here with a stir bar and be stirring it while we're adding something in from a burette. So a magnet kind of takes care of all those problems for us. So we're going to put on our safety gear. And then let me add in our first amount of liquid. So we're going to use vinegar. Think to yourself, is vinegar an acid or a base? Vinegar is an acid. Which acid is it? Vinegar is acetic acid. Now, in a titration, we're going to have a color change. So one of the helpful things you can do for yourself is set up 2 beakers with the same initial solution. That color change is going to guide us. So we're going to have this as a comparison. And when I see a difference between the color of the 2 solutions, I'm going to stop right away. Now I'm going to start stirring this, and you can see as my little stir bar gets going, it forms a nice little vortex. There we go. Okay, in order to have a color change happen as this reaction proceeds forward, we need another molecule in here. Meet Phenolphthalein. Phenolphthalein is what we call an indicator. So, what makes something an indicator? An indicator is a compound that has two forms. One of the forms we call it has an additional hydrogen ion attached. We call that the acidic form. Another form has the hydrogen detached. We call that a basic form. Now, in order to be an indicator, these two forms of phenolphthalein need to be different colors. So in our case, the acidic form of phenolphthalein, you can see right now, is clear. The basic form of phenolphthalein is going to be pink. So what happens is, right now we have acid, we're going to start to add base. And as we add base, it's going to react with the acid and turn it into water and salt. So as our reaction goes on, we're going to get less and less and less acid in here. Now we're going to hit a point where we have added so much base that we have neutralized all of our acid. At this point in time, our phenolphthalein is still going to be clear, but one more drop of our base means that extra drop of base has no more acid to react with. So that extra base just floats around and it flips our phenolphthalein into the basic form, which is pink. So when we still have acid in here, it's going to be clear, 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 clear. As soon as we get that one extra drop of base, our solution's going to turn pink. And that's when we know we have reacted all the acid in our beaker. So let's take a look at this and see what it looks like. Now, in order to do this, we need to add sodium hydroxide, which is going to be our base, into our burette. Sodium hydroxide comes in this trustworthy little jar. Actually, it does have a label. Notice my super trustworthy looking label. 3 molar sodium hydroxide. So when I need to fill up my burette, am I going to take the top off and pour straight into my burette? No, don't ever do that. Whenever you are pouring from a giant jug, here is a technique tip. You always pour into another container first, and then you use that smaller container to pour in to your burette. That's called pouring technique, and it sounds very, very simple, but you would be surprised how many students pour directly from shady looking jug into very small tube. You don't want to do that. Always pour into a smaller, more controllable container first. Also, when you pour into a burette, you want to use a funnel. And be careful because the funnel is going to drain slower than the burette actually fills up. Okay, here is titration tip number 2. When you first fill this up with base, you want to do what we call a rinse. You want to fill it up with base, completely drain it out the bottom into a waste container. That's called rinsing your burette. If you don't rinse your burette, whatever is left in there before could affect the concentration of your base. If it's water, it'll dilute your base, and your base won't be the concentration you think it is. If it's acid, it'll neutralize your base, and your base won't be the concentration you think it is. So you rinse through once with base into a dump container, and then you fill it back up and mark where you start. Here's your next technique tip. You must know at the beginning of your titration what your starting volume is for your base and what your starting volume is for your acid. Now, I'm just going to show you a titration, and we're not actually going to collect the information and do the math behind it today. We'll do that in lab. And so I didn't measure out my acid very carefully, but if this was a real titration, you would need the volume of whatever's in your beaker, and you need the volume of whatever's in your burette. You also need the concentration of one of them. One of them is your unknown. One of them is your known. You need the concentration of your known. You are probably figuring out the concentration of your unknown. Okay, next tip. Burettes are kind of difficult to read. So let's take a starting mark for our burette, and I'll show you what I'm talking about. Okay, so our burette right now is at 2.5 milliliters. So write that down. Our starting amount is 2.5 milliliters. Okay, we want to get this as close as we can. Keep that magnet spinning as much as we can. All right, so we're about to start this. And I'm going to show you what happens as we add base. See how pink appeared and then disappeared? So wherever you see pink, you have excess base, and then it disappears in the solution, and that means the base has reacted with acid, and what's left in our solution is acid again. Now, when you do a titration, you want to know how much base you add by the drop. So here is another titration technique. The first time you run through and analyze your unknown, you do not want to add your base drop by drop by drop. That's going to take you forever. So what we do first, we call a quick and dirty dilution. We're just going to let the base run until we find the endpoint. And then once we find that endpoint, we have a ballpark of how much base it's going to take us to get to that endpoint. So then you're going to run a titration a second time. And then the second time you run it, you let the base in until it gets close, and then you go drop by drop by drop by drop to get your very specific amount. So most times when you do a titration, you're going to run the titration at least 2 times. Let me get the camera close here so you can see what's going on. Again, as soon as we see a color difference, we are done. Okay. Let's see if I can hold it there and run the burette at the same time. See that extra pink and how it flows in and then goes away? You are watching a neutralization reaction in action. How cool is that? So this is our quick and dirty dilution. We are running the dilution quickly to get a ballpark of how much base we need to add. Then we'll run the dilution a second time and do it more carefully to get an exact amount of base. Now we are getting close because you see that pink lingering a little bit more. And as soon as I see a difference in a color of these 2 solutions, I'm done. If it keeps disappearing, then we're not done yet. Welcome to titration. It can be a mesmerizing experience, and it can be a frustrating experience. Okay. And I just ran out of base in my burette, so I need to reload that. I'm going to add exactly 50 milliliters so that I don't have to figure out another starting amount. I can keep with that 2.5. Okay, exactly 50. Let's keep going here. Okay, so you see I've hit it. I am obviously pink here. And I would call that an overshoot. I have overshot the end point here. I've added way too much base. And that was a matter of a pour and an end. But at least now I have a ballpark of how much base it's going to take me. And then I can rerun this titration, and at the end I can go drop by drop by drop. And hopefully your ending solution is going to be more of a light pink. As soon as it's not a clear, when it's any shade of pink at all, it is officially done. Okay, so my ending base amount, let's measure that. So it started, if I started with 50 plus, and then I was at like 47 and a half. So I started at, oh my gosh, okay. So I definitely added from 2.5 down to 50. So how much did I add? This is why burettes can be tricky to read, because the number that you read them at is not necessarily the amount that you have added. So if I started at 2.5 and I added to 50, it's actually the difference that I added. So I added 47 milliliters. And then I started at 0 again, and I added to 4.41. Okay, so I added 4.41. So we would have to add those two in order to get the volume that I added. Okay, so like I said, burettes are a little tricky to read. It is definitely worth practicing how much, kind of figuring out how much volume you actually added to make sure that you know how to do it correctly. Okay, and that's a titration. So we have neutralized all the acid in here with our base, and then we added a little bit more base, and our phenolphthalein turned from the acidic form, which is colorless, to now the basic form, which is pink. And we call that the endpoint. So there you go. There's your intro to titration. Welcome. We'll talk a little bit more about the math in the next video, and then we'll actually do this in lab.